And welcome to this on maths prediction for the Legacy Edexcel GCSE Paper 1 for higher tier. Enjoy! And welcome to this on maths paper. We're looking at the Legacy Edexcel GCSE Paper 1 higher paper today. Now this is quite close to the exam. Obviously the exam's on Thursday, so hopefully you'll find this useful. The paper is on the On Maths site, and there's probably a link in the description, and there's probably one popping up just as I speak now, so you can do this online. The servers are at maximum capacity at the moment. If you have problems accessing the paper, just try it at a later time. It's not going to be a problem. I'm going to look at hosting an alternative site on our UK site soon, so hopefully that will help as well. I hope you enjoy this paper and good luck on your exams. Okay, so this question is all about scatter graphs. Now with scatter graphs, I look at them and the first thing I need to do is draw a line of best fit. So a line of best fit just is a line that goes with the data and roughly try and get the same amount of points above and below the line. Don't sit there and count them. If there's 10 below and 1 above, then it probably needs to move down a little bit, and same vice versa. But if there's 10 above and 8 below, don't rub it out and redraw it. They're very lenient over the lines of best fit. Two very radically different ones still get the mark normally. Now, the reason I've done that is because most exam questions with scatter graphs will need a line of best fit, but sometimes they don't ask you to draw one. So draw one anyway, and you probably will get a mark either on question A or B or C or whatever. Okay, first question says, what type of correlation does the scatter graph show? That's obviously going to be negative, and the reason being is the more this one goes up, this one goes down. So as maths results go up, history results go down. The other option is positive, and that's where the maths results go up, history results go up, the line goes up. And there is a third option, which is very rarely used, but it could be used on maybe a 1 mark question, is where it's no correlation. That's when all the points are everywhere. You can't draw a line of best fit. Now, since I could draw a line of best fit, there obviously is a correlation. Now, question B says another student got 24 on their history test. Estimate what they got on their maths test. So the most common mistake here is not reading the axis. The history test results are on the left-hand side, not the bottom. And the way of doing this and making sure we get the mark is just draw a line across from 24. Now, my ruler is a bit thick, so hopefully I'll get it. There we go. So you draw a line across where it hits the line of best fit, and a line down from that point. So let's try and get this semi-right. There we go. Okay, and so reading off, that person we predict will get 34. Now, this is another question that there might be different answers. Everyone who drew a line of best fit, well, if they got it slightly different to another person, they'll get a slightly different number here. The working out for this question is what I've just drawn on the scatter graph. Again, the question didn't ask you to do a line of best fit, but for that question to absolutely guarantee you'll get the mark, or marks, okay, you have to draw a line of best fit and show that you're drawing a line across and down. Also, on some of the exams, you can actually be quite far off, and as long as you've done that, then you still get at least 1 mark, even if your answer's not quite right. Now there's multiple ways of answering this question. I'm going to do the non-calculator method, but if it comes up on the calculator exam, then it might be a different way of doing it. Or there will be a different way of doing it. So I'm going to do grams and cost. The information we're given is 1 kilogram of cheese costs £7.70. £7.70. So I'm going to first of all convert that £7.70 into pence. So it's a lot easier to work with. I'm going to say cost in pence. Okay, and instead of 1 kilogram, I'm going to say 1,000 grams. Kilo is always 1,000, so kilometers, or kilometers, is 1,000 meters, kiloliters, 1,000 liters, etc. Now we need to get this so it's 600 grams, which is what it's said in the question. So I need to bring it down to something that's easy, something I don't need a calculator for, and then bring it up. So let's have a think. Well, if I bring that down, if I divide that by 10, and if I divide this one also by 10, then that will bring us down to 100. And I can divide that by 10 without a calculator, 77. And then if I times that then by 6, then I'll get 600. So I need to times that by 6. And this is slightly more complicated, so I probably need to do a little grid. Probably should use a ruler. Okay, so 77, and I'm timesing them. 7 times 6 is 42. Add the 0. 7 times 6 is 42. And let's add them together. And there's loads of different methods of timesing. This is the most common one, although there's much different ones than this. And it's 462 pence. Now the answer shows that it wants it in pounds, so I just need to write £4.62. Now with a calculator you could always divide it by 1,000 and find out the price of 1 gram, and then times it by 600 to find the price of 600, and there's loads of different ways you could do it other than that. Okay, so there's a few different ways of answering this question. I'm going to go through one method. If you've come up with a different method and you can show all you're working out and all the stages, then that's fine. So I'm going to work out this one first, which I'm going to call A. And A is going to be 180 minus 129, which is 51 degrees. And that's because it's angles on straight line adds to 180 degrees. Okay, so the next one I can work out is angle B. So B also equals 51 degrees because it's an isosceles triangle. Okay, next one I can work out is this one up here, which I'm going to call C. So C equals 180 take away 51 times 2. So 51 times 2, let's do that first. 51 times 2 is 102. So that's going to be 78 degrees. And the reason is angles in a triangle. Angles in triangle add up to 180 degrees. Okay, last one I need probably is this one here, which I'm going to call D. And D and the 129 here create a C angle between the parallel lines, which we call interior angles. And interior angles add up to 180. So it's 180 take away 129, which we did earlier, which was 51 degrees. And we need to write down that they're interior angles. Now, if you're a bit puzzled and think, oh, hang on, I've never heard of interior angles, some teachers call them co-interior angles, some teachers call them allied angles. With the other two, they must be corresponding and alternate, but with interior angles, there are different words that you can use to describe them. Okay, so we've currently got D here, we've got C, and we're looking for X, and they make a straight line. So to work out X, it's just 180 take away the D and C, so it's 51 plus, what was it, 78. Okay, so let's do 51 plus 78 first. So 50 plus 70 is 120, so it would be 129. Let's just check that. 50 plus 70 is 120, plus the 9, 129. And so we do 180, take away 129. If I add 1 to 29, it makes 30, and that means I've got to add another 50. So that equals 51 degrees. And it's angles on straight line. Now there are different ways of answering this question. If you have got B there, then B and X create a Z angle or alternate angle, and there are loads of different other ways of doing it. I've kind of gone the longest way because then I can show all the different stages of working out, but if you've got a shorter way and it makes sense and you've written down the reasons along the way, then that's fine too. Okay, so the place to start with this question is, what transformation is it? So you just need to ask yourself a few questions. Has it been reflected? Does it look like a mirror image? Well, no, it doesn't on this one. Has it been rotated? Has it been flipped around? No, they're the same way up. Has it got bigger or smaller? Well, no, it hasn't. It stayed the same. And if the answers to all those questions are no, 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 then we're left with translation. Now, translation just means it's moved. So the first answer, the first bit of the answer, is just saying it's a translation. Now, they might not give the mark anymore for that. It might be a 1 mark question, so we need to make sure we get the next bit. So to describe a translation, you need to pick the same point on both the shapes. Now, I always pick the top left point, but it doesn't really matter as long as you're consistent between the two shapes. So I'm going to pick the top left on A, and I'm going to pick the top left on B. And the first thing you do is find out how many jumps does it take to go left or right from A to B. So I'm going to start on A, and I'm going to keep going left or right until I line up with the mark I put on B. Well, I'm not going to go right, I'm going to go left. So I go 1, 2 jumps left. Okay. The next thing I've got to do is go up or down until I hit B. Well, it's going to be up, so it's going to be 1 jump, 2 jumps, 3 jumps, 4 jumps. Now, the way of showing how, like, that it's gone 2 left and 4 up, you used to be able to just write 2 left and 4 up, but they don't like that anymore because that's not very mathsy. We use things called vectors. Now, vectors have a number at the top which says how far right it's gone, and a number at the bottom which shows how far up it's gone. The problem with this one is it hasn't gone right. So the way of showing left is dead simple. You just put a minus. So it's gone -2. So if you think about it, it's gone right -2, which is left 2. And it's gone 4 up, so we put the 4 there. Now, a common mistake, and I stress the word mistake, is to put a line between the two because people are used to writing fractions. You don't want to draw that line. Okay, and sometimes markers might look at that and go, oh, actually, is that a fraction? No, we can't possibly give the mark. They're fair markers, but if you do something non-mathematical, they will penalise you, or mostly. And that's it. And you could write translation by the vector. So we could, in this bit here, by the vector. But I've not seen that on any mark schemes. I think if you've got translation and the brackets, that's fine. Okay, so it's not uncommon on the exam to have a page or a big question full of algebra, and sometimes they lump expanding and factorising together, so let's go through these ones. Okay, so the method I do for expanding linear brackets is smiles and rainbows. I do a smile, then a rainbow, and then I normally just put a notch there to remind me to times it. I do a little time sign there. So the first thing I'm doing is 10 times 3x. So I always start off with the signs. It's a positive times positive, so the answer's going to be positive. Then I do the numbers, 10 times 3, which is 30. Then I do the letters, well, it's just x, isn't it? Then the rainbows, they're both positive. 10 times 2 is 20, and there's no letters. So it's just going to be 30x plus 20. This next one I've got to do it twice, so I'm going to do a smile and rainbow on the first one and a smile and rainbow on the second one. So first thing I'm going to do is I'm going to show my working out to this, so don't try and do this straight to the answer thing because it's a little bit of working out first. 10 times 3, oh it's exactly the same as the last one, so it's 30x. Now both the next two are positive, so 10 times positive 2, so it's plus 10 times 2, which is 20. Now the next one is minus 5 times 4x. So a minus times a positive is a minus. 5 times 4 is 20, and we've got that x. Now the rainbow on the second bracket is the one that almost everyone gets wrong. It's minus 5 times minus 7. So a minus and a minus make a plus. 5 times 7 is 35. Okay, let's collect the like terms. So 30x take away 20x is going to be 10x. And then we've got 20 plus 35, which is 55. So my answer is going to be 10x plus 55. Okay, the next one is a quadratic, and there's loads of different ways of doing this. You can use foil, you can use smiley face, double smiles and rainbows. There's loads of different ways of doing it. So what am I going to do? I'll do foil this time. So first, outside, inside, last. So the first two is 11x times x, which is just 11x squared. I do a little squared sign. Outside is 11x times 3, which is going to be 33x. Next one is the inside, which is minus 2 times x, which is minus 2x. And last one is minus 2 times 3, which is going to be minus 6. So when I put those together, the two that normally add together are these two. Okay, not always, but normally. So my answer is going to be 11x squared, because there's no other x squared, so that just stays as it is. Then we're doing 33x, take away 2x, which is 31x. Take away 6. Let's put that in my answer box. Okay, next one it says factorize, and it looks like it's a single bracket. So let's put a single bracket down. So first thing I look at is there a number that I can divide out? Well, 30 and 20 are both in the 10 times table. I don't think there's any larger ones. Now you could have picked 2, but you have to pick the biggest number that you can divide out, which is 10. Now we've got an a squared and an a, so I can divide out an a. Now what do I times 10a to get to 30a squared? Well, I'll need a 3 and I'll need an a. The 3 and the 10 make the 30, the a and the a will times together to make the a squared. Now what do I times 10a by to get to 20a? Well, it's going to be positive 2, 2 times 10 is 20, and the a is on the outside, so I don't need an a on the inside. So fully factorised, it is this. Now you can check your answer by just doing smiles and rainbows on it. So 10 times 3, 30a squared plus 20a. So it works. And you can leave the exam with a big smile on your face because you know you've probably got it right. Now the last one is a quadratic. So we're going to put 2 brackets down. Now looking at this, there's no coefficient on the y squared, there's no number before it. So it's just going to be y and y. Now to do these ones, you've got to find 2 numbers that add together to make the minus 11 there, and times together to make the 28 there. Now this is not easy, it's a little bit of trial and improvement, but I know that the 2 numbers add together to make a negative, but times together to make a positive. So the only way you can do that is if they're both negative, which is a bit of a head start. Now I'm thinking what times what is 28, and I'm thinking, oh okay, 28 is in the 4 times table. Let's just do a 28 grid. So I know it's 1 times 28, that doesn't work. 2 times 14. Well, those don't add together to make 11. Okay, and obviously here we're meaning minus 1, minus 28, minus 2, minus 14. It's not in the 3, so minus 4. So what times minus 4? It's going to be 7, isn't it? Now what is minus 4 plus minus 7? Ah, that works. Minus 11. So it's minus 4 and minus 7. Now that is a very, very tricky one. But that's the right answer. And again, you can use FOIL on it to check. I'm not going to do it, but you can use FOIL on it to check that you've got the right answer. Okay, so the rules of indices are if you times together two powers with the same base, and by base we mean the big number. On this one it's A, so we've got A and A. What you do is you add the powers. Okay, so this becomes A to the power of 4 plus 7. 4 plus 7 is 11, so it's A to the power of 11. Now the next rule of indices is if you've got a power inside a bracket and a power outside of a bracket, you can times them. So it's m to the power of 3 times 6. So it's m to the power of 18. Now the reason both those rules work is a to the power of 4 is just a times a times a times a, and then we're timesing it by a to the power of 7. So a to the power of 7 is a times a blah blah blah. So we've got 4 of them here and we've got 7 of them here. This next one is m to the power of 3, which is m times m times m, and we're timesing it by itself 6 times. So we're going to do m times 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 m. We're going to do that 6 times. So 1, 2, 3, 4, 5, 6. So in total we will have 18 m's together. Okay, so for this next one, this is a slightly harder one. What you need to do is just do the numbers first, then we're going to do the r's, and then we're going to do the s's. Okay, so 27, so over means divide, okay, so 27 divided by 9 is just going to be 3. Now this is r on its own. Now r on its own is r to the power of 1, and we're dividing it by r to the power of 7. Now when you times powers, you add them. When you divide them, you take away. So we're going to be doing r to the power of 1 minus 7. 1 take away 7 is just minus 6. And then we're doing s to the power of 14 divided by s to the power of 6. 14 take away 6 is 8. Okay, so the first thing to realise with this question is we need to find out the volume of the swimming pool. And to do that we need to understand what shape it is. Now it is a prism with quite a weird trapezium end. So it's a trapezium based prism. So we need to work out the area of the trapezium and times it by the length. So the volume is the area of trapezium times the length. And the length normally with a prism is how 3D it is. It's the one left over. So we've got to work out the area of a trapezium first. Now the first thing to realise is that 3.9 meters is also the height of this bit as well as this bit. So we've got a trapezium that is 40 meters across, and the two bases are 3.9 and 4.1. Now to work out the area of a trapezium, you do half a plus b. Now a and b are the two parallel ones, so that's a and that's b there, and it doesn't matter which way around you put them. So 3.9 plus 4.1, and it's times the height. Now the height is actually a width, isn't it? but the height is the length that connects the two bases, the two parallel lines. It has to hit both of them at 90 degrees, which it does. So that's times 40. And as I said before, the length is how 3D the prism is. Now you'll be careful because you need the cross section to face you, but more or less, mostly they do. So it's times 10. Okay, 3.9 plus 4.1 is 8, and half of 8 is 4. Okay, 4 times 4 is 16, so 4 times 40 is 160. And then that's going to be 1,600, and that's meters cubed. Although we don't need to necessarily show our units until the end. I've kind of gone to the end of the volume, so I'm just going to show it's meters cubed. Okay, now it says that it fills up a rate of 20 meters cubed per minute. So every minute it's going to fill up 20 meters cubed. So this tells me, so I'm going to say time, this tells me that I'm going to have to divide it. I'm going to find out how many 20s there are in 1,600, and that'll tell me the amount of minutes it will take. Now I'm going to do this as a fraction, because I'm going to pretend this is a non-calculator question, although it could be a calculator or non-calculator. When you write it as a fraction, what you can do is just divide top and bottom by 10, so it becomes 160 over 2, and then divide top and bottom by 2. So it's 80 over 1, and 80 over 1 is just 80. So it's going to take 80 minutes. Now you could do this other ways. If you had a calculator, obviously you just divide it on the calculator, or you could do the bus stop method. Although I think with this one the fraction method is much easier. Okay, so this question looks really complicated, but there's a very easy way of doing it, and that's to construct a two-way table. So I'm going to construct the two-way table first from all the information, and I notice there's a lot of information that says total, so I'm going to make sure I have a total column in this two-way table. And so we've got the different subjects. Okay. So what have we got? We've got male, we've got female, and then we've got total, and then we've got maths, we've got English, and we've got science, we've got total. Okay, 123 students attended the session, so the total of the totals is 123. They picked one subject. Some of them went to maths, right? Okay, so 59 of the students are female, so the total females is 59. Okay, 24 of the 48 students who went to English are male, so the total for English is 48. And 24 of them were male. 31 of the students went to science. So 31 went to science. 26 males went to maths. So 26 males went to maths, which would be this one. Okay, so that's just the information given to us on the table. But what we can do is fill out the rest of them. So either calculator or non-calculator. To get this first one here, okay, what I do is 123, which is the total, and there were 59 females in total, so that leaves 64 males. So 64 plus 59 is 123. Okay, if I know that one, then let's have a look and see which one we're trying to find out. Work out the total number of females who went to science. So we're trying to get this one here. Okay. So if I get this one here next, so what I want to do is I want to do 64, take away the 24 males who went to English, take away the 26 males who went to maths, that leaves 14 males who went to science, and there were 31 scientists in total, and 14 of them were male, and that leaves the answer of 17. Now there's different ways of doing that. you could have gone a different way. We could have started down here and tried to go along here, which is absolutely fine. That would have worked as well. And you didn't have to do the two-way table, but when I've marked these types of question before, the students who consistently get them right are the ones who do a two-way table, so it might not be a bad idea. Okay, so this is a standard recipe question, and the important thing to realise is that these ingredients are for 16 and we want to try and get 24. So I can't go straight from 16 to 24. Well, I can, but without using fractions. So what I'm going to do is I'm going to work out how much I need for 8, and then I'm going to times that by 3 to get 24. Okay, so to find out how many 8, obviously we're going to divide them by 2, and then we're going to times them by 3. So for 8, okay, so half of 96, well half of 90 is 45, half of 6 is 3, so that's going to be 48. Half of 80 is 40, half of 48 is 24, and half of 2 is 1. And then what I can do is just add the 16 and the 8 together to get to 24, or I could times the 8 by 3. So the first one's 48, and I just want to times that by 3, or add the 96, you still get the same answer, it's 144. Then I want to times the next one by 3, or add it to the 80, which makes 120. If I draw it right. The next one I want to times that by 3, and that gives me 72. And the last one I want to times that by 3, which is 3. So it's 144, 120, 72, and 3. Okay, the next one says I've got only a kilogram of self-raising flour, but enough of the other ingredients. So first thing to realise is that 1 kilogram is 1000 grams. And we know for, 16, so for 16 we need 96 grams. So therefore for 160 we will need 960 grams, so just times them by 10. Okay, so we've got 40 grams left. Now the problem with this is we need probably to work out how much 1 is worth. So with the 96 making 16, I want to do how many 16s there are in 96. So first 96 divided by 16. So to make 1 I need 6 grams of self-raising flour for 1 biscuit. So how many 6s are left there? Well, there's 40 left, so 40 grams left. And so what I want to do is I want to do 40 divided by 6, which means, 6 times 6 is 36, so I can have another 6. So I can have this 160, and also I can have another 6. So that's 166. Now you could have done this with a calculator straight away by just doing 1000 divided by 6. And when you do that on the calculator, 1000 divided by 6 is 166.66, or 6 recurring I should say. Don't need that one. And that means we can get 166 biscuits and we'll have some left over. So the amount of biscuits we can make is 166. So you can do this with or without a calculator. First thing really is to work out how much 1 biscuit needs, how much flour 1 biscuit needs, which was 6 grams, which we worked out here. And find out how many 6s there are in 1000. Okay, so a simple standard form question. Now the best, easiest way of doing this is first of all write the decimal down, 9.6, and although you're discouraged from moving the decimal point at all times,
On standard form, I find it much easier. Now, first thing to notice, if the power of the 10 is negative, which it is here, it means we've got a very small number. If it's positive, we've got a very big number. Now, we need to know this because if we're going to have a very big number, we're going to jump the decimal point to the right. If we're going to have a very small number, which we do here, we're going to jump it to the left. Now it says -7, so we're going to jump it 1, 2, 3, 4, 5, 6, 7. So the decimal point is going to end up here. Now all those jumps that we did, we need to fill them in with zeros. And you normally start a decimal with 0 point, so we're going to add another 0 there. So it's going to be 0.00000096. Don't ever put 2 decimal points in, okay? We've moved the decimal point to the new position. You'll never have a decimal with 2 decimal points. Now I'm just going to double check the 0, so 1, 2, 3, 4, 5, 6. We've got 1, 2, 3, 4, 5, 6. Perfect. Now to make a number standard form, write the number out, 23500. Okay. And first of all, work out where the decimal point is now. Well, if it's not shown, it's always at the end of the number, so it's here. Now we've got to figure out where we want it to go. Now the number in standard form, the decimal that precedes it, or the number that's before the times 10 to the power of something, has to be between 1 and 10, but not 10. Okay, so if I move the decimal point, so if I'm going to jump it, so we're going to do 1 jump, that's not quite right, that's going to be 2,350, that's way above 10. 2, that's 235, still above 10. 3, that's 23.5, we're close, but we're still above 10. And 4. If we put it in there, then we get 2.35, which is between 1 and 10, and we jumped it 4 times. Now remember what I said before, if it's a big number, it's a positive. If it's a small number, it's a negative. Well, this is a big number, 23,500, that's a big number. So it's going to be positive, and it's going to be positive 4. Okay, my advice with all these questions is always draw a diagram. So I'm just going to draw a line and I'm going to put the various places on it. So we've got Chiltern, which I'm going to call C, we've got Devley, which I'm going to call D, we've got Bocco, which I'm going to call B. Okay, so I'm just going to put the information on. There's 31 miles here, and there's 10 miles here. And there's, what is it, average speed of 62 miles per hour. Okay, so we need to understand the speed distance time triangle, which I can quickly draw here. And it just means, well, you just got to remember distance at the top. Speed and time doesn't matter which way around. You cover up the one you're looking for and it shows you how to do it. So the first one, we're looking for the amount of time it's going to take. So I'm going to cover up the time, okay, and it tells me that it's going to be distance divided by speed. So the distance is 31, so I'm going to say CD time. Let's just get rid of that. It's going to be the distance, which is 31, divided by the speed. And 31 over 62, well, that, if I divide top and bottom by 31, that becomes a half, so it's half an hour. So we know if it's 9 o'clock here, that he leaves Chiltern, he'll be at Devley at 9:30. Now the question says, how quick does he have to go to get there for 9:45? So that's 15 minutes. So we know that the distance is 10 miles, and we know it's a quarter of an hour he's got. Okay, so looking at the speed to distance time triangle again, let's just put time back. So what we're going to cover up, well, we're looking for the speed, so I'm going to cover up speed. It's distance over time. Okay, so dB speed is distance, which is 10, over time, which is a quarter of an hour. Now, over just means divide, so this is the same as 10 divided by a quarter. How many quarters are there in 10? Well, if you're good with fractions, you'll know you can do same change flip. Same change flip. 4 over 1 is just 4, and that's 40. So you'd have to travel at 40 miles per hour. Now, you can do that on the calculator, or you can do the non-calculator method, which I've shown here. Okay, so this looks like quite a complicated question, and it's complicated because there's lots of bits and lots of things going on. Now, the first place to start might be to figure out this block here, or it might be to figure out this block here. And it doesn't really matter which one we start, but I just think the second one is a bit easier place to start. Let's work out how many merit points we have. Now, we've got the money, but the £16 8 pence is in pounds, and the 3 pence for each merit point is in pence. So I'm going to show the examiner I'm working out how many merit points. So merit points. Okay, so I'm going to see how many merit points they have. Okay, so first of all, I'm going to change the pounds into pence. So I'm going to make it 1,608 pence. And if each one's worth 3 pence, then to work out how many we've got, we just divide it by 3. And I'm going to do this over on the right hand side. So I'm going to do the bus stop method. So 1608. 3's into 1 don't go, that makes that 16. 3's into 16 go 5, carry 1. 3's into 10 go 3, carry 1. 3's into 18 go 6. So 536 merit points. Okay, next we need to work out how many James, Sarah and Robert have. Now the way of doing this, and this is quite common with algebra type questions, is you're going to have an expression for the total merit points, and we're going to have it in algebra, and we're going to have it as a number. Now, as a number, we already know it's 536, but in algebra, we're going to put James's down, which is x. That's a nice easy one. And we'll put Sarah's down. Now, Sarah has 3 times more than James. Well, if James has x, Sarah will have 3x. And to work out our total, we add them together. So I'm going to put a plus there. Now, Robert has 49 fewer than James. So he has James's x, take away 49. Now, whenever we solve, always put lines down, okay, where the equal sign is. Now I'm just going to collect the like terms. So x plus 3x plus x is 5x. I'm not going to do anything with anything else just yet. Okay, now we've got a minus 49 there, so to get rid of that I'm going to plus 49 both sides. Okay, and so we've got 5x equals, now to add 49 you can add 50 and take away 1. So when I add 50 I get 586, so this will be 585, so take away the 1. Okay, we're going to then divide by 5 both sides, and again I'll need the bus stop method. So how many 5's in 5, 8, 5, 1 goes into 5, 1 goes into 8 but I carry 3, and 7 go into 35. So x equals 117. Now James has x, so it's going to be 117 for him. Sarah has 3 times as many, so I could do this in my head, but I'm not going to. I'm going to do this using the grid method. So it'll be 100, 10 and 7. Okay, so it's 330 and 21, and so it's going to be 351. And Robert has 49 and fewer, so it's going to be 117, take away 49. Okay, so I'm going to have to borrow 1 from there to make that 17. 17 take away 9, it's going to be 8. I have to borrow that 1 to make that 10. 10 take away 4 is 6, so 68. And again, I could have taken away 50 and added 1. Okay, and that's it. Okay, a little tip for these types of question. Whenever you're given a shape, you're either working out the area or volume of the shape, and sometimes the perimeter in the context of the question, and there normally will be some marks for doing that. Because we're covering this floor, we're looking for an area. So I'm going to start off this question by working out the area of the trapezium, which this shape is. And it's a trapezium because it's got one set of parallel sides, and the parallel sides are always the A and the B, and the one connecting them at right angles is always the H, and the formula is half A plus B H. So it's basically the mean average of A and B. So it's going to be half 2.2 plus 1.8 times 11.5. So 2.2 plus 1.8 is 4, and half of 4 is 2. 2 times 11 is 22, so that's going to be 23. So it's 23 meters squared. Now it says that the tiles are sold in packs which cover 3 meters squared. Okay, so I need to work out the packs. Well, if I do 7 times 3, that gives me 21. Now 21 is not going to be enough, so I need to do 8 times 3 to get 24. Now you might say, well, 24 is more than 23. Well, you know, unfortunately you're going to have 1 left over, but that's just the way it is. So it's going to be 8, so we're going to have 8 packs. Okay, now let's have a look at the next bit. There's 25% off the marked price, and then marked at £18. So I want to work out 25% of £18. Now to find a quarter of something, which is 25%, you halve it, then halve it again. So half of that is 9, and a quarter of it is therefore half of 9, which is 4.5. So it's going to be £4.50. So the price is going to be 18 take away 4.5. 18 take away 4 is 14. Take away 0.5 is 13.5. So £13.50. So each packet, each pack of tiles is £13.50, and I need to get 8 of them. So the last step is to do 8 times £13.50. So I'm going to do this as in pence. So that's going to be 8,000 there. That's going to be 24 2 zeros. That's going to be 40 with a 0. So it's going to be 8,000 plus 2,400 plus 400. Okay, so the 4 plus the 4 is 8, and the 8 plus the 2 is 10. Okay, so that's in pence, so that's going to be £108. Now, it says that Jenny has £100. How much extra does Jenny need to buy the tiles? And to give your answer in pence. So it's £108 it's going to cost. She's got 100, so I could write that down for the examiner. 108 take away 100, which equals £8, which is 800 pence. So the answer is 800 pence. Okay, so for advanced mean questions, and I mean the average mean, not just difficult questions, it pays to know that actually the mean is a type of triangle, just like speed, distance, time and density and all those ones. So we work out the mean by doing the sum, that just means add the numbers together, over the amount of numbers. Now the reason it's helpful to know this as a triangle is sometimes in the advanced questions they will give you the mean and the amount, or the mean and the sum, and they'll ask you for something else. They might ask you for the amount or the sum. So with that in mind, we can work out the total, or the sum, of the boys. So the mean of the boys is 11, and the amount of the boys is 15. So we just, using the triangle, we just times them together and we can work out what the sum is, or total is. So 10 times 15 is 150, add another 15, 165. Then we can work out the total of children. Same process. The mean of the children is 17. And the amount of children was 15 boys, 10 girls, so that's 25. And I can just do a grid. If you've got a calculator, then obviously you can use a calculator. That's 200, 14 with a 0, 50 and 35. So let's add those together. 200, 140, 50, 35, 9, 10, 11, 12 and 4. So 425. So the total of the children is 425, the total of the boys is 165. So therefore the total of the girls is the total take away the boys' total. So 425 take away 165. So that's going to be 0. I'm going to have to borrow one off that. So that's 6, 2. So that's 260. So all the girls added together is 260. But it's asked for the mean number of coins for the girls. So mean of girls. And we just use the standard sum over amount. So we know that they add up to 260. And we know that there are 10 girls in total. So that's going to be 26. Okay, so whenever you see this type of question, it's about similarity. The two triangles, the small one and the big one, are mathematically similar. So you can work out a scale factor. Now, it might help sometimes just to draw out the small one. Not connecting very well, but anyway, let's draw out the small one, and let's draw out the big one. Okay. Ooh. And then let's label the sides. So that's 4 centimeters. That's 12. Now this little one at the bottom is x. Now this one here is actually x plus 4. And a lot of students will treat that as 4 and get the wrong answer. That's x plus 4 because it's 4 here and there's an x there, so it's x plus 4. So, first thing to do with similarity questions is work out what the scale factor is. The scale factor, to get from 4 to 12, we times by 3. The scale factor is 3. So, we know that we are going to times that by 3, and it will equal x plus 4. So if I do that now, So 3x, 3 times the x equals x plus 4. And it just becomes a simple solving question where we just need to solve what x is. So we're going to take away x from both sides, and it becomes 2x equals 4 and x equals 2. Let's just check that. If x is 2 there, then that makes that 6 and the original one 2, and 2 times 3 does indeed equal 6. So it says find the length of x, and the length of x is 2. Okay, so to start off this question, the most important thing we realise is it's a circle inside a square. So we know one of these measurements already, so we know that's going to be 40. Okay, most of these shaded areas we're going to find the area of the big thing, find the area of the small thing, and normally take them away. So let's first of all work out the area of the square. Okay, which is going to be 40 times 40. So 4 times 4 is 16, and then the 2 zeros. Okay, so next we're going to do the area of the circle. And area of the circle is pi r squared. Now r is the radius, and we're given the diameter. We're given the full way across the circle. So it's going to be pi times 20 squared, because that's half of the diameter. Okay, 20 squared is 2 times 2, which is 4, and then add the 2 zeros, which could be 400 pi. So what we want to do is we want to work out the area of the total missing bits. So area of total space, I'll call it. And I've shaded it in so the examiner can kind of understand what I mean by total space. And that's just going to be the area of the square, take away the area of the circle. Okay, so now we need the shaded area. And to do this, we simply divide the area of the total space by 4, because the yellow bits here we don't want, and each of these 4 corners are the same area, we just divide it by 4. So it's going to be this, which we worked out before, all of that divided by 4. So 1600 divided by 4 is 400. And 400 pi divided by 4 is just 100 pi. Okay, if you'd like to pause the video, otherwise let's get started. So we have a new planet that is that weight, and we've got the mass of the Earth. So we've got 2 masses, and we're asked how many times heavier is the new planet than Earth. So if the new planet was 10 and Earth was 2, then to work out how many more times heavier it is, we just divide it. It would be 5 times heavier. This time we don't have simple numbers, we've got standard form. So the new planet is this. And Earth is this. So we just divide them. Now the way of dividing these is we pair up the numbers together. And we pair up the 10 to the powers together. Okay, so 3.02 divided by 6.04. Well, if you write that as a fraction, you'll see that the top number, the 3.02, is half as big as 6.04. So the answer to that is just 0.5. Then with powers, if you divide, you take them away. So 24 take away 21 is 3. Now the problem is this isn't standard form. If I write this out, so we'll do 0.5 and it's to the power of 3, so it will be 1, 2, 3. Let's fill those in with zeros. So that's equivalent to 500. And the decimal point's there, so when we move the decimal point back to make it into standard form, we jump once and twice. So it's 5 times 10 to the power of 2. 5 times 10 to the power of 2. Now the reason it wasn't standard form before was this number has to be between 1 and 10, not including 10. When working with box plots, we first of all need to understand what the 5 points of a box plot are. We always have the lowest value on the left, then the lower quartile, then the median, then the upper quartile, and then the highest value on the right. And those 5 points will always be plotted on a box plot. You might be asked to plot them yourself, or they might be given to us. So to find the median, it's just the middle one. So let's have a look. It's halfway between 8 and 10, so that's going to be 9. The interquartile range is the distance between the lower quartile, which is the second one, LQ for lower quartile, and the upper quartile, which is the fourth one. So you just need to take them away. So it's upper quartile, so interquartile range is upper quartile, take away lower quartile. Upper quartile is halfway between 16 and 18, so 17, and the lower quartile is 8. So we're doing 17 take away 8, which is 9. So they're both 9. Okay, whenever you're asked to compare two distributions, you're always going to be comparing the medians and the interquartile ranges, or just the ranges. Now since we've already worked out the interquartile range for the first one, I'm going to compare the interquartile ranges. So I'm going to first of all compare the medians, so let's have a look. So on my one here, so what is this? This is the dogs, is 9, and the cats is 16. So we write a statement such as, on average, and what are we saying? The cats scored higher, or made more errors. On average, the cats made more errors. And always just write down the medians of the cats and the dogs as well. I'm not going to, but write down the fact that the cats has a median of 16 and the dogs had a median of 9. Okay, that makes it really clear. Okay, the second one is comparing the interquartile ranges. So I'm just going to show the examiner that I'm doing the interquartile range of the cats. So it's going to be 20 take away 13, which is 7. So let's compare them. The cats had 7 and the dogs had 9. So I would say something like the spread of the errors was larger for dogs. And again, write down the fact that the dogs had an interquartile range of 9 and the cats only had an interquartile range of 7. And that just shows how spread out our data is. So the cats were more consistent with their data, the dogs were a bit more spread out. Okay, if you want to have a go, pause the video now, otherwise let's get started. Okay, so this is actually a lot more complicated than it first seems. We're asked to find the angle ODF, which is this angle here. Now what you need to get used to in these questions is to show all of your working out and reasons. Now I'm not going to write down the reasons, but I will read them out. So this first one, first place to start is this one here, okay, but you could have started elsewhere. This one I know is going to be 90 take away 32, because I know that the angle between the radius and a tangent is 90 degrees. So when I work that out, that's 58. So I know that's 58 degrees. Okay, the next one I can work out is this little kite shape here, which has a 90 degree here and a 90 degree here. So I know that all quadrilaterals add up to 360. So I know that 360 take away two lots of 90 is 180. So to work out this angle here, I just need to do 180 take away 22, which equals 158. So that is 158 degrees. And that's just angles in a quadrilateral, and the angle between a tangent and a radius is 90 degrees. There are other ways you can work that out, but I'm not going to go into them. Okay, so if I know that this one's 158, I also know this one here, because the angle at the circumference is half the angle at the centre. So I just need to do 158 divided by 2, which equals 79. And every time you do working out, you need to give reasons in brackets afterwards. Okay, I'm not going to write them down because it would take too long. So that's going to be 79 degrees. And remember, that one is angle at the circumference is half the angle at the centre. Then this one here I can work out because it's angles on a point. So it's 360 take away 158. So that's going to be 202 degrees. I just need to make sure I put degrees on these. Okay, then we've got an arrow shape here, which is a quadrilateral. So we need to add up 202, 58 and 79 and take it away from 360. So I'm going to do 360, take away, and I'm just going to add up all of the lengths that we know. And then that equals 21 degrees, which is our answer. Okay, so we're given an equation here, y equals x squared minus 2x, and we've given a partially filled out table. So the first thing we're going to do is just complete the table. So if x is 0, then x squared, 0 squared is 0, minus 2 times 0 is just 0. So that's a nice easy one to start. Let's work our way down. So 3 squared is 9, take away 2 times 3, which is 6. So 9 take away 6 is 3. And 4 squared is 16, take away 2 times 8. 2 times 8 is 8. So it's going to be 8. Okay, minus 1 squared is 1. Minus 2 times minus 1 is plus 2. So that is going to be 3. Now you might notice that there's a symmetry here. So if I have a look at these ones here and these ones here, they're the same. Now you'll find that with a quadratic graph. Don't rely on it 100%, but if you've got 830 and then 039, then just check the value that looks like it's different to the symmetrical one. Okay, next thing we're going to do is plot this on the graph. So minus 2, 8. That's going to go here. Minus 1, 3. 0, 0. 1 minus 1. 2, 0. 3, 3. 4, 8. If it's a quadratic, it should be nice and symmetrical, which mine is. If you've got one that looks out of place, then just double check that you've done the calculations right. Now I am awful at drawing these, but there are a few rules with drawing quadratic graphs. First of all, it doesn't want feathering, which is like this. It doesn't want that. It wants just one continuous curve like that. Okay, and I'm going to try my best here. Make sure you go for all the points. So I'm going to try my best here. And make sure at the bottom it's a nice smooth bottom on it. If you have 2 points at the bottom that are the same height, make sure you dip between them. Okay, there's the rules. Right, I did stop halfway through, but I think I've just about got away with it. Okay, the last question says to solve this little equation here, which says x squared minus 2x equals x plus 1. Now you might notice that the left hand side of this we've just plotted. The right hand side of it, well, we haven't got that. So what you need to do is just plot the left hand side equation. So we want to plot y equals x plus 1. Now y equals x plus 1 is a gradient of 1 and the y-intercept is 1. So I'm going to plot the y-intercept as 1, and for every 1 we go across it goes up 1. So I'm going to just do that, and you could do this with a table of values. That would be fine as well. I'm going to go the other way, so for every 1 to the left it goes down 1, like so. Let's join it up. Like that. Excellent. And the solutions are where this graph and this graph hit. Okay, now you can see that they hit at this point here, which looks like it's let's have a look. It's x equals minus 0.3, it looks like. But they also hit just here. So let's have a look at what that is. That looks like it's x equals 3.3. And there's our two solutions. Okay, so we're asked to solve these simultaneous equations. You might notice that the coefficients, the numbers before x and y, are different. So what we need to do is make one of them the same. Either the x is the same or the y is the same. So let's call this a and b. Now if I have a look at a, if I do 2a and make that 4x, then it's the same x coefficient as y. So I'm going to double everything in equation a. So I'm going to double the y as well. And I'm going to double the 24 to make it 48. And I'm just going to rewrite b underneath. So 4x minus 3y equals minus 4. Okay, now with simultaneous equations we work downwards. So we're looking at these two numbers here, looking at these two numbers here, and we're looking at these two numbers here. Be careful that you look at the signs as well. Now we want to get rid of the x's or the y's, but the y's are different coefficients, so we want to get rid of the x's because they have the same coefficient. Now if you think about it, with 4x and 4x, how do we get rid of them? We're either going to add or subtract them. Well, we're going to have to subtract them, because if we add them we get 8x. And if we're subtracting those, we're subtracting everything else. So we end up with nothing here. Okay, there's nothing. 4x take away 4x is nothing. Now here we've got 10y minus 3y. Two minuses make a plus, so that's going to be 13y equals 48 minus 4. Again, two minuses make a plus, so that's going to be 52. Let's draw our lines down the side. And we're going to divide both sides by 13 to get rid of the 13 and 13y. So it's going to be y equals, and 13 times table goes 13, 26, 39, 52. So that's going to be 4. So y equals 4. Now we need to substitute y into one of the equations, and I might pick b. It doesn't matter if you pick a. So let's pick b. So it says 4x minus 3y equals minus 4. So it's going to be 4x, and I know y is 4, so it's going to be minus 3 times 4, which is 12, equals minus 4. Put my lines down, add 12 both sides, so it's 4x equals, and that's going to be 8, and divide by 4 both sides. X equals 2. So let's check that, and again, if you've got time at the end of the exam you can check this. So let's substitute them both into a. Now a is 2x plus 5y equals 24, so let's just check that works. So 2 times 2 is 4, and 5 times 4 is 20, and yes, that does equal 24. So we've got y equals 4 and x equals 2. So we're asked to convert the recurring decimal into a fraction, and it's quite a difficult one. So we've got the 2.1 that we're going to have to deal with, and we've got the 0.047 recurring that we've got to deal with. And I'll probably deal with them separately. So this one is quite easy. If 0.1 is 1/10, then this would be 21/10. Okay, that would make 2.1. So that's the easy bit. Now, the way I do this recurring one, is I just think, okay, so what's 0.47 recurring as a fraction? So if I call that x, then to bring the numbers in front, I'm just going to delete that arrow, so normally do this on top. I think, right, what's 100x? Well, that's 47.47 recurring. And let's take them away, so it's 99x is going to be 47 take away 0 is just 47. And the two recurring bits will just take away, they will just cancel each other out. Divide both sides by 99. And so x is going to be 47 over 99. Now that's 0.47 recurring, we've got 0.047 recurring. So what's the difference between this bit here and this bit here is all we need to do is just divide that by 10. And with fractions, when you divide by 10, you just times the bottom by 10. So what you want to do is just do, so let's just show the examiner what I'm doing. It's just going to be 47 over 990. Okay, so we've got our fraction here, and we've got our fraction here, and we need to add those together. So we need to do 21 over 10 plus 47 over 990. So we need the bottoms the same, so I need to times top and bottom of this first fraction by 99 to get the bottoms the same. So the bottom one is going to be 990, which is the whole point of it. And so we need to do 21 times 99. Well, what I can do is times 21 by 100. And let's do this down here to make this, and then just take away 21 from it. So that's going to be so 10 take away 1 is 9, 9 take away 2 is 7, that's going to be 0, and that's going to be 2. So it's 2079 over 990. We're going to add the 47 over 990, and with the bottoms the same, we just add the tops. So we're going to do 2079 plus 47. 6, 1, that's going to be 7, 8, 12. So that's going to be 2126 over 990. Now it says in its simplest form. Now they're both even numbers, so I now can divide top and bottom by 2. So let's have a go at doing that. So I can do it with bus stop method, why not? 2's into 2 go 1, 2's into 1 don't go, 2's into 12 is 6, 2's into 6 are 3. So it's 1063, and then half of 900 is 450, half of 90 is 45, but again I can just do the bus stop method. 990, right, 2's into 9 go 4, carry the 1, 2's into 18 go 9, carry the 1, and 2's into 10 go 5. So it's 495. Now, I don't think I can cancel that anymore. You could probably spend hours and hours trying to cancel that. I assume that I can't cancel it anymore. I think with maths sometimes you just look at it and go, not quite sure I can do any more with that. The top one, it doesn't end in a 0 or a 5, and it's not even, so chances are I can't cancel it anymore. There we go. Okay, for this question it's really easy to understand the question by not understanding what that squared does. Now, as soon as you walk into the paper and you see a bracket squared, just write out the bracket and then write out the bracket again. So many times I see students timesing the 10s together and timesing the root 13s together. So, loads of different methods of working this out. It's very similar to when you do quadratics, although it's with surds. You can do the first outside, inside, last, the smiley face, double smiles, rainbows, whatever method you choose. I'm going to be doing FOIL, but I don't mind which method you want to do. And so we're doing first, so 10 times 10, which is 100. Outside, which is 10 times root 13, which we write as 10 root 13. And that doesn't look like a 3 at all. Okay, so inside, which is root 13 times 10, which again we write as 10 root 13. And last, which is root 13 times root 13. Now, anytime you times a surd by itself, it just becomes the number. So it's technically root 169, which is 13. Okay, so all of these are pluses because there's no minus in it. So to put these together, we've got 100 plus 10 root 13 plus 10 root 13 plus 13. So the 100 and the 13 go together, so 113 plus we've got 10 lots of root 13 plus 10 lots of root 13, which is 20 lots of root 13. So it asks for what A and B are. So A is 113 and B is 20. Okay, the first thing to realise with this question is to work out frequency density there is a triangle. Isn't there always a triangle for everything? And the triangle is frequency at the top, frequency density, and class width at the bottom. Now this is a bit of a weird triangle because actually it's not quite right, because the frequency density is proportional to the frequency divided by class width. So sometimes the frequency density will be twice as big as you'd expect. So you do frequency divided by class width and it will be half as much. Or you can divide it by 3 or divide it by 4 or 5 or whatever number you want. So that's not quite accurate, but for our purposes, as long as we remember frequency density might be a different number, but it will be proportional. So if one of them you have to times by 2, you have to times them all by 2. So I'm going to do the class width column first, and the class width is just the width of the group. So 0 to 10, the class width is just 10, 10 for the next one, then 20 to 25 is going to be 5, and I'm writing small here, and 25 to 35 is 10, and then the last one is 15. So that's the class width sorted. And the frequency density then is just the frequency divided by class width. So we're just going round and just dividing them all. Okay, so 7 divided by 10 is just 0.7, and then 10 divided by 10 is just 1. 6 divided by 5 is going to be, what, 1.2? If I can draw it. See, I'm writing too small here. Let's try it again. So 1.2. 9 divided by 10 is going to be 0.9. And 6 divided by 15. Oh, that's going to be quite a tricky one. So let's do the bus stop method for this. Can I do the bus stop method? Or so I could do it as a fraction. 6 divided by 15, and I notice that I can divide top and bottom by 3, so that's 2 over 5, so it's just 2/5, which is going to be 0.4. There we go. There's always a way. Right, so we've got our frequency densities. Now we've got to figure out what scale to do on the left hand side for our frequency densities. Well, our highest number is this 1.2 here, so we need it to at least go up to 1.2. So if I go up in 0.2s, 0.2, 0.4, 0.6, 0.8, 1, 1.2, that would be perfect. So I'm going to go up in 0.2s. 0.4, 0.6, 0.8, 0.9, almost. 1.0, I'm just going to put 1.0 because it's a bit easier and it looks nicer, and 0.0. Okay, so we're going to start drawing the histogram. Now to do the histogram we just need to make sure that we have the correct ranges. So first one's 0 to 10, and it's similar to like a bar chart. So we're going to go up to 0.7 for the first one. So it's going to go up here, it's going to go across to 10, and then down. It's not perfect, but we can cope. Next one is 10 to 20, so we're going to go up to 1. Okay. Next one is 20 to 25, so we've got to be careful here. So this says it's 1.2, so we're going to go up to 1.2, across, and we've got to be careful, we'll go to the right place, because it's only 20 to 25. And what's the next one? 25 to 35, so 25 to 35, and it's going to be 0.9. And the last one, 35 to 50, is 0.4. There we go, and that's our histogram. You probably will need to draw it a little bit more precisely than I've managed on this. Okay, so let's have a look at the next question. The next question says that work out an estimate for the number of trees greater than 40. So if I draw a line up at 40, and we're looking for these guys. Now the total frequency of that bar is 6, and I've drawn a line that cut off, if I shade it in, I've cut off a third of it, so it's gone a third of the way. So we're looking for 2/3 of that 6. Well, 2/3 of 6 is just going to be 4. The answer to question B is 4, because there's 6 in total and we're looking for 2/3 of it. Okay, so this question relies on your knowledge of sine and cos waves. The first one is just a basic sine wave, and you should know that sine and cos work in sort of units of 90. So point A is 90 on the x-axis, and point B is 180 on the x-axis. Now at point A, all sine and cos waves go up to 1, so sine goes up to 1, and point B is at 0. That's a nice easy one. Now this second one is much harder. If you imagine there's a different graph of f of x equals just cos x, what's happened with this equation here? Well, we have x times by b inside the function, and then we've times the function by a, and then we've added c on the end. So what do each of those bits do? Well, that affects the x coordinates. Basically that squishes it in if it's a positive number, sorry, if it's a number higher than 1, and it stretches it out if it's a decimal. So let's have a look at what we've got. We've got a normal sine curve would start here and end at this point here. Okay, but we've got not just one of them, we've got 3 of them between 0 and 360. So we've got 1, 2, 3. That means that B is squishing in 3. So B equals 3. Okay, the number on the outside shows us how far it's stretched in the y direction. Now this works as if it's a number greater than 1, it stretches it out. If it's a decimal, it compresses it in. So what's happened? Well, we'd normally expect it to be between 1 and -1, and so it's got a period range of 2, or on the y-axis it's got a range of 2. Here it's between 3 and -1, so it's doubled its height, so therefore A is going to be 2. And the C at the end here tells us how far it's shifted on the y-axis. If it's outside the function, it goes on the y-axis. Well, as said before, it would normally be at 1, and it's now moved up to 3. So it's moved up 2. So therefore C equals 2. Okay, if you want to pause the video now and have a go, otherwise let's get started. So, whenever you're just asked to simplify a fraction on its own with algebra in it at this stage of the paper, it's probably going to require factorising. Now you sometimes get a difference of 2 squareds, so look out for that. However, both of these are just standard boring quadratics. I say boring. Difference of 2 squareds are interesting, so therefore these are less interesting. So we're going to have 2 sets of brackets at the top and bottom. It seems the coefficients of all of them are x. So I notice we get a -20 at the top. So 2 numbers are multiplied together to make -20. Well, they've got to have a difference of 1. So they've got to multiply together to make that, and add together to make that. So they've got to add together to make 1. It's going to be +5 and -4. 5 times -4 is -20, so that works. And 5 take away 4 is 1, a positive 1, so that works. Now, I know for this question to work that one of the ones at the bottom has to be the same as the top. So that might give me a bit of a hint. So let's get started with the one at the bottom. So they're both plus, so both of these have to be plus. And they times together to make 35. Well, 4 doesn't go into 35, so it's probably going to be 5. Let's try it and see if it works. 5 times 7. Let's try that. 5 plus 7 is 12, so that works brilliantly. And then all you need to do is just cross off the x plus 5 from the top and bottom, because we're dividing top and bottom of that fraction by x plus 5. So that just leaves us with x minus 4 at the top and x plus 7 at the bottom.
Thank you very much for watching this video, and I hope you found it useful. Don't forget you can do this paper online on the website onmaths.com, and you can save your scores if you log in, or you can just not log in, and that's absolutely fine. It's completely free, and there's a whole load of other stuff on the site that can help you out. We're looking at doing paper 2, which obviously there's no paper 3 for the legacy one, so we're looking at doing paper 2 as soon as we can. So we'll get that up on the site and hopefully up on YouTube as soon as we can, and we'll look at taking off all the topics that came up in paper 1 so that you can just focus on the topics that are likely to come up for paper 2. If you enjoyed this video, please click like. If you really enjoyed it, please click subscribe. Thank you very much.